Ever wonder how astronomers detect planets in other solar systems? In modern astronomy, one of the most exciting developments of the last few years has been the discovery of exoplanets, planets that orbit stars other than our Sun light years away. They've been hypothesized since the 16th century when they were first proposed by Giordano Bruno. The first two confirmed exoplanets were discovered in 1992. Since then, astronomers have discovered 860 more exoplanets, and the list is growing all the time. How do we detect exoplanets anyway? They don't emit light like stars, and they're often too small for us to see directly. Instead, we can observe them indirectly by measuring changes in how their host stars appear in our telescopes. Astronomers have developed two main ways to detect exoplanets. The first way is called the transit method. In astronomy, a transit happens when a small object, in this case a planet, passes in front of a larger object, in this case the host star. When this happens, the star appears to get slightly dimmer for a period of time. By measuring the temporary loss of brightness as well as the time it takes for the planet to cross, we can make estimates about the planet's size and distance from the star. This method works great, but only when the planet, the star, and the Earth are in a straight line. When they don't line up, astronomers need to employ a different method to detect exoplanets, known as the radial velocity method, or Doppler spectroscopy, or the wobble method. This method relies on the fact that when a planet revolves around a star, the planet exerts a small gravitational force of its own on the star. As the planet goes around, it pulls on the star, much like a heavy object swinging on a rope pulls on the person doing the swinging. The star then wobbles around at the same rate as the planet orbits. When astronomers observe the star, they can't see the planets orbiting around, but they can see the star wobble back and forth. By tracking how long the wobbles last and how far the star wobbles from the center of the system, we can find the masses of the exoplanets, how long their orbits last, and how far the planets are from the star.